Alright, so we are talking about trapezoids today.
This is Paris, not hard.
That's, like I said, you guys can find all of my typos. It's fine. Alright, so a trapezoid is a quadrilateral with exactly one pair of parallel sides. The parallel sides are called bases and the sides are called legs. So a trapezoid. That's a trapezoid. We have two sides that are parallel. The other two sides clearly aren't. The two sides that are parallel, those are both a base. And then the other two sides are legs. Okay? The legs are not necessarily congruent. They can be. Another example of a trapezoid. This is also a trapezoid. Okay, this is also a trapezoid. We have got two parallel sides. So this would be our two bases. And then we have the two legs. Okay, so a trapezoid doesn't have to look like what our typical trapezoid in our mind looks like, but it can also have some different looking legs. An isosceles trapezoid is a trapezoid with congruent legs. So what can I mark on here to make this into an isosceles trapezoid? Yep, I can put tick marks on the legs, and now this is an isosceles trapezoid. Okay, so now we have two theorems dealing with an isosceles trapezoid. So here I'm going to redraw one out so we can label our diagram accordingly. So there's my isosceles trapezoid. So if we have an isosceles trapezoid, both pairs of base angles are congruent. So your base angles would be the two angles attached to the same base. So those two angles would be congruent, and these two angles would be congruent. Okay, so if I told you this bottom left angle here was 60 degrees, what does this angle have to be? 60. Okay. The other thing we know about isosceles trapezoid is the diagonals are congruent. Okay, what is that the same as? What other shapes had diagonals congruent? Squares and rectangles. Rhombus did not, no. So we're going to use that type of information to help us decide if we have isosceles trapezoids or not. So for the first example, I think we're looking at 4 points and we're deciding if we have an isosceles trapezoid. Yep. Use JKLM. So there we have 4 points. We first want to verify it's a trapezoid. And then we want to determine if it's an isosceles trapezoid. Okay. So how could we verify something is a trapezoid? Yeah, only two sides are parallel, the other two sides are not. And then how can we check to see if it's isosceles? Yep, two sides are congruent, or we could look at the diagonal as being congruent. Either way. Okay. So verifying this is a trapezoid. You could certainly graph this, but I do want us to do one where we're not graphing, where we use the formula. So here's our slope formula. So we're going to find the slope of our four sides. So one of our sides would be JK, and then KL, be the next side, LM, be the third, and what would be the last one? MJ. Okay, of course, you could also graph this and count. That's fine. But I want us to do one example where we're not graphing and counting. Okay? So JK, y2 minus y1. So 8 minus negative 1. 9. Over negative 6 minus negative 18. 12. 9/12, what does that simplify down to? 3/4. Okay, KL. Y2 minus Y1. So 1 minus 8. So -7 over 18 minus -6. 24. Can that be simplified? Nope. Okay, LM. See, we got -26 minus 1. What's that? -27 over -18 minus 18. -36. -27 over -36. Divided by 9, so what is that? 3/4. Okay, and the very last one, MJ. Oh, Y2 minus Y1 first. Yeah, so -26 minus -1. -25 over. Yeah, -18 minus -18. Oh, this is minus a negative though, so it becomes 0. This just means we're undefined, so we have a vertical line. So are two of these slopes parallel? Yep. JK and ML. These are parallel to each other. So there we verified it was a trapezoid, and all of this work was verifying that it was a trapezoid. Okay, so that's part A. And like I said, of course, you can graph those and count, but this one would have been difficult to graph with -18, -26, right? We would have had a pretty large piece of graph paper. So the second part is determine if we're an isosceles trapezoid. So we have two ways. We can check that the diagonals are congruent, or we can check that the two sides are congruent, the two sides that aren't parallel. Which way would you like to do it? Two sides that aren't parallel. So the two sides that aren't parallel are KL and MJ. Okay, so though we have to find the distance for those. So remember our distance formula, our change of x squared plus our change of y squared. So from K to L, how much do our x's change from -6 to +18? 24, so 24 squared plus 7 squared. Okay, well, what's 24 squared? Yeah, maybe get a calculator out. 576. There you go, 576 plus 7 squared? 49. So when we add 576 and 49, what do we get? 625. Square root of 625 is equal to 25. Okay, so we have the distance between those two sides is 25. All right, now let's do the distance between M and J. So M and J, change of x squared. So our x's go from -18 to -18. 0. So 0 squared plus -1 to a -26. 25 squared. 0 plus 25 squared is 625. So we once again have the square root of 625, so 25. So determine if JKLM is isosceles. So is it? Yes. And we know it is because KL is equal to MJ. Does that make sense? Do we need to see a second example like that, or are we okay with just that one example? We're okay with just that one? Yeah, the other one's just like this. We do the same steps. First the slope and then the distance. Okay, so that was this one. So we'll skip over this example and we'll go to the next ones. QRST is an isosceles trapezoid with median XY. There's no diagram, so we're going to have to draw it out. Oh, there is one on yours? QRST. Is that the way how it's drawn out? Oh, shoot. This is what I get for not importing my diagrams. QRST with the median XY. X is on the left, thank you. Okay, so there's our diagram. So, that'll come down to this one. So for this one, if QR is 22 and XY is 15, we want to find TS, and we're told that XY is the median. Okay, so what do we know about the median? Median's the middle. So how do you think you'd find the median of an isosceles trapezoid? Okay, so we divide it by the overall. So we would need to take our two base lengths, so 22 and whatever this base length is, we'll call it x. We'd have to add those up and divide it by 2, and that would give us the median. But what's our median here? 15, so we can now just say it equals 15. Okay, can we now solve this for x? What could we do first? Okay, so times by 2. So now we have 22 plus x is equal to 30. So what's your x? 8. So that's your TS is 8. Is that okay? All right, so now using the same diagram, we are given some measurements for angle 1 and angle 3, and we want to find everything else. And they're labeled like this: 1, 2, 3, 4. Okay, so angle 1 is 4a minus 10. And angle 3 is 3a plus 32.5. Okay, good. So angle 3 and angle 4 would be congruent to each other. And angle 1 and angle 2 would be congruent to each other. What would these four angles have to add up to equal? 360. Now, if the four angles have to add up to be 360, and these two are the same and those two are the same, what would like 1 and 4 have to be? 180. Okay, so if 3 is the same as 4, this is also 3a plus 32.5. Yep, so we can add these to equal 180. Okay, so combine our like terms together. What do we have? 4a plus 3a, 7a
Plus 22.5.
Yep, plus 22.5 is equal to 180. No, we have negative 10 plus 32.5. So we've got to combine them. Okay, so subtract 22.5. So what would we have then?
157.5.
157.5. And then what would we do?
Divided by 7.
Divide by 7. So what's our A?
2.5.
Okay, I want to find the measure of angle 1, angle 2, 3, and 4. So what do I do with this 22.5 now? Plug it in. So we can plug it into this 4a minus 10. So 4 times 22.5 minus 10. So it's 4 times 22.5.
It is 90.
And 90 minus 10 is 80. So angle 1 is equal to 80 degrees. What other angle then is 80 degrees? So angle 2 is also 80. Do we really need to plug it into angle 3, or could we just think of it as they add to equal 180? So angle 3 then would have to be 100, and angle 4 would have to be 100. Does that make sense? Okay, let's do one more example then. Okay?
So you plug it back in?
Yeah, we just plugged it back in.
Wait, how did you know 2 was 80 as well?
Because this is an isosceles trapezoid. So isosceles trapezoids say those two base angles are equal. Okay.
You want to look at the next diagram?
This one's drawn this way, right?
Yep.
Where does D start?
Bottom left.
Bottom left, so this is D? Thank you. So D, E, F, G is an isosceles trapezoid with median MN.
Yep.
All right, EF is 20, MN is 30. We want to find DG. So EF is 20, MN is 30. We want to find DG, so we want to find X.
So we can just put 20 plus x over 2 equals 30.
Yep, 20 plus X divided by 2 should equal 30 because MN is the median. Median's halfway in between them. Okay, so multiply by 2. So we have 20 plus X is equal to 60. So X is 40. So our DG is 40. Is that okay? Okay, and once again, we're going to use that diagram to find the angle measures. And so it's the bottom left. Okay. So 1, 2, 3, and 4. Angle 1 is...
No. Angle 1 is right there, and angle 2 is G.
Oh.
Yeah. And then
2.
3 right there.
Man,
Switch to the 4 and 3.
holy cow, did I label that diagram wonky. It's like that?
Yeah.
Wow. Okay, angle 1 is 3x plus 5, and angle 3 is 6x minus 5. Yeah, we have these two, so they're going to add to equal 180 because it's an isosceles trapezoid. Plus 6x minus 5 is 180. Yep, 9x is 180 because the plus 5 and minus 5 cancel. Okay, so x is 20. So plug it in. So 3 times 20 plus 5? 65. So angle 1 is 65 degrees, which means what other one is? Angle 2 is 65. So what does angle 3 have to be then?
1.
Yep. 180 minus the 65? 115. So then angle 4 is also 115 degrees.
I like this stuff.
Does that make sense?
It will be like, I don't even know.
Yeah, like last
Pretty-
year.
What do you mean?
Yesterday and like the day before, or even like
With the factoring. Okay, I didn't go through factoring with you. It's algebra 1's a prereq for this class. I assumed you remembered it. Page 442, you're doing 11 through 18, 22 to 25, 44 to 48.